Now on to h4. Let's go ahead and look at it. h4.c. Again, we're dealing with matrix times vector. We malloc the memory, and it's the proper size. We initialize it. We perform the multiplication, and we return the pointer to the vector. Down here, we have our matrix call, show vector. We don't have a free here. We won't worry about that initially. Let's go ahead and try to build this and see if it's successful. Oh, that looks good. So let's go ahead and make this do a little extra work for us. So now we'll do 2 matrix vector multiplications. And show both vectors. There we go. Save that. Build it and run it. And everything looks just fine. Well, not quite. There is one problem here that we really should fix. We perform these allocations within the matrix times vector functions, but we don't clean up after ourselves. So let's clean up our allocations here by calling free. It's always good to be a good memory citizen. We'll build this, run it, and we have a lot of information here. Now, what you're seeing is a crash dump. Specifically, our lines ran, but then we received this error in free. We have an invalid next size. So the question is, what does that really mean? 2 things here. We've got a backtrace that shows us what was actually called. And then we have the memory map that shows us what data there is. And we could go through this memory map and try to get a good idea of what's failing. What we really want to do is use our tools that are available to us. So I'm going to go ahead and run valgrind on this. Now, the nifty thing about valgrind is it will run, and here's those 2 lines. It thinks it successfully exited, but it does tell us there are 2 errors, and here are the errors up here. Invalid write of size 0, and it tells us that the place that it was trying to write was at this particular address. It is 0 bytes after the block of size 40 that was allocated. So we're actually writing data past the end of our array. Now, what's past the end of our array? Well, that's information that the allocator needs in order to manage the memory blocks that are being allocated. Let's go ahead and take a look at our code and see where we possibly are overwriting the end of our vector. Well, chances are it's up here in the multiply. Here's where we perform the allocation. Now, I'm going to skip over to the actual multiply here, and everything looks fine here. I starts at 0. It does not exceed n, so this should be fine. But this looks questionable. We start at n plus 1, and then it decrements. But the question is, does it decrement before it stores 0 in the array or after it stores 0 in the array? And the answer to that is it actually does not perform this decrement until after it stores the value in the array. Now, that means we're storing a value in n plus 1, well past the end of our array. Let's fix this loop up and see if this corrects our problem. I'm just going to delete the content of this And we'll start off 0. I equals 0, I is less than n, I plus plus. We'll write this out. We'll build it, and we'll run it. Success. Big problems happen whenever you exceed your array bounds, and this goes both directions, whether you're writing data outside or after the end of your array, or even before the beginning of your array.